Welcome back to the Python Praxis and to part 2 of our exploration of Python lists. In the previous video, we discovered what lists are and how to access their elements with precision. Now it's time to take things further. In this part, we'll see how lists can actually evolve. We'll add new elements, remove old ones, and reshape them on the fly. We'll also look at essential operations, checking whether something exists in a list, measuring its length, sorting its values, and even reversing them. And of course, we'll tie everything together with hands-on examples and practical exercises so you can see lists in action just like you would in real-world programs. So let's dive right in and start bending lists to our will. Python lists aren't just readable, they're dynamic containers. You can add, change, remove, or reorder elements easily using specific built-in methods, which are part of the list's class definition. Think of a list as a flexible drawer. You can drop in new items, insert things in specific slots, or pull things out when you don't need them. To add elements, .append method adds an element at the end of the list. .insert method adds an element at a specific position. .extend method adds multiple elements from another list. To remove elements, .pop method removes and returns the element at the index number position. The default case, in case we do not put any index number inside the parentheses, is the last element. .remove method removes the first occurrence of a value. .clear method empties the entire list. Let's practice modifying some lists. We start by defining a list of two colors, red and green. Using the append on colors, we add blue at the end. Then using insert on colors with arguments 1 and yellow, we insert yellow in position with index 1. I remind here that this is the second position in the list as we have 0 indexing. Finally, using extend on colors, we extend the colors list with few more colors. Now, we will remove items from a list of fruits. We use pop without any argument to pull the last fruit from the fruits list, and we assign it to variable last fruit, since the pop function returns the value of the element it removes. Using pop on fruits with 0 as argument, it removes the first element from the list, the apple. So when printing the fruits list now, we get only the banana. In another example, let's look at the list numbers that contains 5 integers. Using remove on numbers list with argument 6, we remove the first occurrence of number 6 in the list. If we want to delete all the elements in a list, we use the clear function on the list. These are basic skills, but critical when prepping datasets, cleaning logs, or filtering responses. Let's examine a list management exercise. We are preparing a dataset for a machine learning model, and we start with a basic list of features. The tasks we have are to create a list with 3 features, age, income, and gender. To check if the education feature is included, and in case it is missing, to add it. Then sort the list of features alphabetically, and at the end to print the final sorted list and the total number of features it contains. Now let's go through the code line by line. The first line defines a list with name features and assigns 3 elements in it, age, income, and gender. Then using the if function, we check whether education is included inside features list, and in case not, our program prints a message to inform us that feature education is missing. After that, using the append on features with education as argument, we append education at the end of the list. Using the sort function on features, we sort the elements in the features list alphabetically. The last 2 lines print the total features in the list, using the len function on features to count them, and the features list sorted alphabetically. This is how we curate feature sets for models. Quality input equals smarter output. In Python, lists come with helpful tools for inspecting and modifying their contents. We use in to check if an element exists in a list, and not in to confirm it is missing. These expressions return true or false and are often used in conditionals. In order to get the total number of elements in a list, we use function len with the list's name as the argument. Function sort on a list arranges elements in ascending order. It modifies the list in place. And function reverse on a list reverses the order of elements inside the list. These are the fine tools to sculpt and shape your data until it's model ready. Ready for some more hands-on work with lists? Here we will write a program that creates a list of integers, checks if a specific number, for instance 5, exists in the list, and prints a corresponding message. checks if another number, for example 10, does not exist in the list and prints a message, prints the total number of elements in the list, sorts the list in ascending order, and displays the result. And finally, reverses the order of the list and prints the final reversed list. In the code, we start by defining the list, called numbers, and assigning to it 4 integers, 8, 3, 12, and 5. Then using the conditional if, else, and in, we check whether number 5 exists in the list. If yes, we print the message, 5 is in the list. Else, if 5 does not exist in the list, we print the message, 5 is not in the list. The next check we do, again using the conditional if and not in, is whether number 10 is not in the list. And if it is not, we print the message, 10 is missing from the list. In the rest lines, we do some data processing on the list. With len function, we calculate and print the total number of elements in the list, the length of it. Using the sort function on numbers list, we sort the elements in the list and print them. And at the end, we use the reverse function on numbers to reverse the order of the elements inside the list and print it. As a last exercise for this lesson, we have the sentiment score tracker. This one is a bit more advanced and more real-world. We are preparing a program that collects 5 unique sentiment scores from the user, with values between 0 and 1 and precision of 1 digit. Our program also validates each input and performs some basic analysis. The steps are: initializes an empty list, collects 5 unique sentiment scores from the user between 0 and 1, sort the list in ascending order, print the list, calculate and print the average, print the number of unique elements. Now we will analyze the code thoroughly. First, we create an empty list called sentiments. This is where we'll store the scores that the user gives us. Next, we begin a loop. This while loop keeps running until we've collected exactly 5 sentiment scores. The condition, len sentiments less than 5, makes sure of that. We're using a try block to safely handle any input errors, like if the user enters a letter instead of a number. Then we ask the user for a score and immediately convert it to a float. We're also showing which score number we're on, using len sentiments plus 1. In the next lines, we check if the score is actually within our expected range, between 0 and 1. If not, we let the user know and use continue to go back to the top of the loop. After that, we check for uniqueness in user's input. This step checks if the score has already been entered. We want only unique scores, so if the value is already in the list, we notify the user and skip to the next iteration using continue. If the score passed all checks, we add it to the sentiments list using the append function. If the user tries to input something that can't be converted to a float, like a word or a symbol, the accept value error will catch it and give a friendly message and go back to the top of the loop. Once we have all 5 valid scores, we sort the list in ascending order using sort function and print the sorted scores. Next up, we calculate the average by summing all the values and dividing by the number of items in the list, using the sum and len functions on the sentiments list. The next line prints the average with just 2 decimal places using Python's fstring formatting. Finally, we print how many scores were submitted. Should always be 5 here, since we controlled that with the while loop. And that's it. With just a few lines of code, we created a safe, interactive program that takes input, checks validity, avoids duplicates, sorts data, and performs a little math too. This is a great exercise to combine multiple key Python concepts: lists, loops, conditionals, input validation, and calculations. Keep practicing, and you'll see how all these small skills come together to form powerful tools. This is beginner-friendly, yet reflects exactly how we clean, validate, and prepare input in data pipelines or AI tools. Awesome work today! You've just taken your first real step into data structures in Python. Lists are everywhere, whether you're managing playlists, sensor logs, user profiles, or model features. They're simple, but powerful. And now, you can wield them with confidence. In the next lesson, we'll level up further, exploring loops in the program flow. Until then, keep practicing, keep exploring, and remember, every line of code is a brushstroke on the canvas of your ideas. See you soon in the next chapter of the Python Praxis.